Greetings and welcome to the Introduction to Astronomy. In this week's exploration of the solar system, we will talk about the spacecraft known as LADEE, and that's an acronym of LADEE, and we'll look at its studies of our moon. So let's go ahead and get started. When we look at the moon, it appears silent, still, and airless. Unlike Earth, it has no thick atmosphere, no clouds, and no wind. But the moon is not completely without an atmosphere. Instead, it has something more delicate, a tenuous exosphere made of individual atoms drifting just above the surface. Understanding this fragile environment was the goal of NASA's Lunar Atmosphere and Dust Environment Explorer, or LADEE, launched in September 2013. LADEE was designed to study the composition of the moon's exosphere, how it changes over time, and how it is affected by outside forces like sunlight and meteoroid impacts. Scientists wanted to understand how this extremely thin atmosphere behaves and responds to the space environment. Even on a world that seems quiet and unchanging, subtle processes are always at work. One of the key questions was how tiny impacts from micrometeorites affect the lunar environment. Unlike Earth, the moon has no atmosphere to burn up incoming debris. Even tiny particles strike the surface at high speed. These impacts can kick up fine dust, launching it above the surface and briefly into space. LADEE observed changes in the lunar dust environment that were linked to meteor streams, confirming that these tiny impacts play an important role in shaping the moon's near-surface environment. The finding is especially important for the future. Dust may pose a hazard to things like landers, instruments, and eventually human habitats on the moon. Understanding how dust behaves is essential as we prepare to return astronauts to the lunar surface. But LADEE carried more than scientific instruments. It also tested a new way to communicate across space. Using the Lunar Laser Communication Demonstration, the spacecraft successfully transmitted data using laser light instead of traditional radio waves. This experiment achieved data rates far higher than previous lunar missions. It demonstrated a technology that could one day allow high-definition video from the moon, faster data from distant spacecraft, and more efficient communication across the solar system. LADEE completed its mission in 2014 after about 6 months in lunar orbit. When its fuel was exhausted, the spacecraft was intentionally directed to impact the lunar surface. In its short life, the mission revealed the moon is not as quiet as it appears. Its exosphere is constantly changing, shaped by sunlight, space weather, and tiny impacts from passing debris. And even the most familiar worlds can still hold subtle and important mysteries. LADEE showed us that the moon's environment is more dynamic than we once thought, and that understanding it is essential for the future of lunar exploration. So that concludes this week's exploration of the solar system on the LADEE spacecraft. We'll be back again next week for another exploration of the solar system video. So until then, have a great day, everyone, and I will see you in class.